Hello there, and welcome to Lost Geology, where quiet curiosity meets the deep end of science, and where wonder is allowed to take its time. If you're listening tonight, maybe you've been looking up a little more often lately. Maybe you've caught yourself gazing at the night sky, not searching for anything specific, just listening to that stillness that hums above everything. So, settle in. If you can, lie back for a while. Let your breath find an easier rhythm. Let your thoughts slow down, perhaps, to the same gentle pace as a drifting planet. You don't have to think too hard. The cosmos has already been thinking for billions of years. Tonight, we're not going to talk about stars as distant lights, or planets as mere rocks in orbit. Instead, we are going to ask a stranger, softer question. What if our solar system isn't just another arrangement of planets? What if, among the endless seas of stars, it's something more unusual, something like a rare cosmic experiment? The word experiment might sound deliberate, as though someone, somewhere, were testing a theory. But perhaps it's not that literal. Maybe the universe experiments in its own way, through gravity and chemistry, through time and chance, through the slow learning curve of existence itself. Our solar system could be one of its grand trials, a carefully balanced test of what happens when order and chaos meet halfway, when a star burns just steadily enough to keep its children alive, when one small, blue planet sits at exactly the right distance, not too close to burn, not too far to freeze, and begins to dream of itself. For a long time, scientists assumed our home system was ordinary, just one in a trillion arrangements, built by the same universal recipe: gas, dust, gravity, time. But then, as telescopes sharpened and data poured in, something unexpected began to emerge. Most planetary systems didn't look like ours at all. They were chaotic, tilted, crowded, strange, with gas giants hugging their stars or super-Earth spinning where Mercury should be. Suddenly, our solar system, this place we once thought unremarkable, began to look unusually calm, stable, almost designed. Not designed by hands, necessarily, but maybe by probability itself, by the deep mathematics of nature experimenting with the balance between destruction and endurance. So tonight, we'll take our time. We'll wander slowly through that question, through the dust and deep time that built our planets, through the science that explains their orbits, and through the quiet wonder that asks if there's meaning in the pattern. We'll explore whether the solar system might be rare, or whether the illusion of rarity is just the way it feels when we finally notice where we are. And as we drift through these ideas, you don't have to solve anything. Just listen. Let the story move at its own cosmic pace. Because the universe doesn't rush its experiments, and neither should we. So, wherever you are, in a city high-rise, in a small quiet room, or under a sky that still remembers the ancient light of creation, welcome. This is where science slows down, where questions are allowed to rest, and where, tonight, we begin to wonder, softly, what if our solar system is a rare cosmic experiment? If you're still with me, take another slow breath, in through the nose, and out through the stars. Let yourself drift a little further from the noise of today, because now, we are going back, far beyond history, beyond the Earth itself, into a time when there were no planets, no moons, no sunrises or shadows, only a quiet cloud, a drifting sea of dust and gas, turning gently in the dark, patient, unhurried, waiting for something to begin. This was our solar system before it had a name, a nebula, delicate, enormous, and unimaginably slow. For millions of years, this cloud hung in space, made mostly of hydrogen, helium, and traces of older starlight. Because before there could be us, there had to be something else, a generation of ancient stars that lived, burned bright, and died, scattering their heavy elements into the dark. The iron in your blood, the calcium in your bones, even the gold in your ring, all of it once belonged to stars that came before the sun. When they died, they didn't vanish, they transformed. Their remains became the seeds of the next creation. And so, around 4.5 billion years ago, gravity, that silent sculptor of the cosmos, began to gather these fragments. Not suddenly, but softly. A subtle pulling, a slow gathering. Grains collided, merged, drifted, and collided again. Tiny sparks of heat were born in the friction. The cloud began to flatten, like dough being rolled into a great cosmic disk. And at the center, a warm point of light began to form, the young sun, glowing faintly behind its veil of dust. If you could watch this happen, you wouldn't see a violent explosion. You'd see a kind of dance, slow, dusty spirals curling inward, billions of particles weaving together like silk threads forming a tapestry, each one obeying gravity, yet creating something far greater than itself. And as the center grew denser and hotter, the first light of the sun began to whisper into the dark. Around it, the leftovers, the remaining gas and debris, continued to swirl. In those soft, swirling layers, the planets began their patient work of becoming. Little by little, clusters of matter collided, stuck together, and grew. Some became rocky, dense worlds near the warmth of the sun. Others, farther away, swelled into giants of gas and ice. Even here, balance was everything. Too fast, and they would shatter. Too slow, and gravity would never take hold. But in this narrow, fragile window of time and temperature, something rare took shape, order from chaos. It's strange to imagine that the calm blue planet you live on was once a fragment in a storm of fire and stone, that the moon above your bed tonight was born from a collision so immense it briefly melted the surface of the earth, that all of this, the oceans, the mountains, even the quiet beating of your heart, traces back to that gentle gathering of dust. If you close your eyes for a moment, you might picture it. You, floating above the young sun, a glowing ember surrounded by rivers of cosmic dust. You'd see glowing streaks of light where collisions spark. You'd hear nothing but silence. No wind, no waves, only the soundless pulse of creation. And in that stillness, you might sense what scientists call deep time, the scale of existence so vast that human lifetimes become like soft ripples on a much larger ocean. Deep time isn't measured in years or centuries. It moves in millions, in billions. It's the rhythm of continents drifting, of stars being born and dying, of galaxies spiraling together like slow-motion hurricanes. And when you think in that rhythm, when you let your thoughts stretch across that kind of time, something inside you slows down too. The noise of the present quiets. The rush of daily life fades. Because in the language of the universe, patience is creation. Perhaps this is the first hint of that cosmic experiment we wondered about earlier. Maybe the universe is not racing toward answers, but testing how long it can wait for something delicate to emerge. How long it takes for gravity and chemistry to stumble upon consciousness. How many trials it performs before life learns to look back and ask why. From this perspective, 4.5 billion years doesn't seem like a long time. It's just one heartbeat of the cosmos. And yet, in that single beat, an entire system arose. Balance between fire and frost, chaos and calm. Planets took their places like dancers finding the perfect step. Moons locked into their orbits. Comets carried messages of water and carbon across the void. And somewhere on one tiny blue world, molecules began to combine in ways that could learn, remember, and dream. So as we drift here, in the stillness of deep time, it's worth asking again, was this inevitability the result of natural laws unfolding as they always would? Or was it something rarer, a fragile moment in an endless experiment, where the universe tried a different equation and found life? For now, there's no need to answer. Just breathe. Let your mind drift through the dust and warmth of those early days, when everything we know was still waiting to become itself. And as you float there, between light and silence, remember, the universe never hurries, and yet, everything happens. Let's stay in that silence for a moment longer. Imagine drifting above the plane of the solar system, not as an astronaut, but as a quiet observer. Before you, the sun glows at the center, its light spreading in every direction, yet somehow finding order in the endless dark. Around it, the planets trace their patient circles. Mercury, quick and restless, closest to the flame. Venus, veiled and glowing. Earth, blue and breathing. Mars, silent and red. And then, the gas giants, Jupiter, Saturn, Uranus, and Neptune, massive worlds whose slow revolutions could lull even time itself to sleep. Everything moves in rhythm. Everything obeys invisible lines drawn by gravity, those gentle tethers that keep chaos from unraveling into noise. And that harmony is not as common as it looks. When astronomers first began discovering other planetary systems, those distant families orbiting other suns, they expected to find order like ours. But what they found instead was something far stranger. Planets crammed close to their stars, larger than Jupiter yet orbiting faster than Mercury. Hot Jupiters, they call them. Enormous gas giants circling so near to their suns that their atmospheres boiled away. Other systems had no small, rocky planets at all, only super-Earths, too massive to resemble ours. Some stars had tilted systems, with planets orbiting at steep, chaotic angles. Some had two suns, where day and night traded places in strange, overlapping rhythms. It turned out that our own solar system, with its neat spacing, its stable orbits, its perfect gradient from rocky to gaseous worlds, was an outlier, a quiet room in a very noisy galaxy. So scientists began to ask, why? Why are we so steady, when the rest of the universe seems so restless? The answer, or at least part of it, lies in the balance of forces that shaped us. Think of the early solar system as a crowded nursery, billions of fragments colliding, merging, and sometimes shattering again. The young sun was fierce then, throwing out flares and gusts of charged particles. Yet even amid that turbulence, certain patterns emerged. Orbits that didn't decay, materials that gathered just so. Jupiter, for instance, played a role so profound that without it, Earth might never have survived. The giant planet's immense gravity acted like a guardian, pulling stray comets and asteroids off deadly paths. Some were captured, some flung harmlessly into the outer dark. A few did strike Earth, of course, but those impacts may have delivered the very water that fills its oceans. It's a strange kind of protection, violent yet essential, as if the solar system itself were balancing destruction and preservation with careful precision. Farther out, Saturn, Uranus, and Neptune continued that pattern, spacing themselves like resonant notes in a long symphony. Their combined gravitational rhythms help keep each other stable. Their orbits don't cross, their speeds harmonize. Even the gaps in the asteroid belt follow these rhythms, places where Jupiter's pull cancels out the sun's, carving silent spaces in the cosmic pattern. When you look at it this way, the solar system feels less like an accident, and more like a piece of music, written not by a composer, but by physics itself. The laws of motion, the pull of gravity, the density of dust, the cooling of time, all coming together to write a song of stability that has lasted billions of years. And yet, not everything was calm at the beginning. There were wild moments too, collisions that shattered worlds, migrations that rearranged the planets. The NICE model, a theory born from computer simulations, suggests that in its early youth, the solar system was far more volatile. Jupiter and Saturn may have shifted their orbits dramatically, pushing Neptune outward, scattering debris across space. That debris would later become the Kuiper belt, a vast ring of icy remnants still drifting beyond Neptune's orbit, like the faint memory of creation. Through all this, something miraculous happened. The chaos settled. Like a child growing into balance after a restless beginning, the solar system found its center. Its orbits synchronized. Its storms quieted. Its temperatures stabilized enough for a world like ours to hold oceans, atmosphere, and the fragile chemistry of life. When astronomers compare this to other systems, they find the odds unusual, not impossible, but rare enough to make one pause. The Earth's orbit is nearly circular, keeping the planet's climate relatively gentle. The sun's brightness has remained steady for billions of years, not too faint, not too fierce. And our moon, born from that ancient collision, stabilizes Earth's tilt, preventing wild swings in climate that might have erased the possibility of life altogether. Each piece fits into the next, like gears in an invisible machine, and together, they create something profoundly stable in a universe that thrives on instability. Perhaps this is just how probability works, the rare event that stands out precisely because we are here to notice it. Or perhaps, as some quietly wonder, it's evidence of something deeper, a cosmic tendency toward balance, towards self-organization, as if the universe, in its vastness, sometimes chooses harmony over chaos, simply because it can. Even the numbers seem to whisper this secret. The ratios between the planetary orbits, the spacing, the resonance, the rhythm, they echo mathematical relationships found throughout nature, in seashells, in galaxies, even in the spirals of your own DNA. The same patterns repeat, as though nature is practicing a melody it never tires of playing. Maybe that's what we are part of, a grand, slow, patient experiment in order. An experiment where time is the scientist, gravity is the instrument, and every planet is a result still unfolding. So as you breathe in, think of the quiet pull that holds everything together, the gravity that keeps Earth in its steady path, the same gravity that keeps your body resting softly against the ground. Both are part of the same force, one vast, one intimate. And as you breathe out, imagine that connection stretching outward, from your pulse to the orbit of the moon, from the Earth to the Sun, from the solar system to the quiet heart of the galaxy. Because in the science of solar order, there's not just mathematics, there's poetry too. The poetry of motion, of balance, of a system that learned to last. And perhaps that's the real mystery. Not that our solar system exists, but that it learned how to stay. Take another slow breath, and let it out, as if releasing a tiny bit of stardust into the night. You're still drifting, softly, weightlessly, among the familiar orbits of our solar system. The sun behind you glows like a silent hearth, and before you, the planets circle in patient, endless loops. From here, everything looks peaceful, inevitable, the natural outcome of cosmic physics doing its work. But there's a thought that sometimes lingers quietly at the edges of astronomy, whispered between the numbers and the nebulae. What if this calmness isn't entirely accidental? What if the solar system, this delicate, balanced structure of light and rock and gravity, is part of something larger? Not a stage built by hands, but a kind of experiment, a trial within the grand laboratory of the universe. When we hear the word experiment, we often imagine scientists in white coats, testing hypotheses, adjusting variables. But the universe, in its immensity, may experiment in subtler ways. It may not decide to create, it may simply allow, testing combinations of matter and energy until something new emerges. In this view, every galaxy is a hypothesis, every star a trial, every planet a result. Perhaps the universe is not random chaos, nor rigid design, but an ongoing experiment in complexity. Each solar system a different arrangement, each with its own potential outcomes. Ours just happens to have found a rare configuration where life could evolve, observe, and ask why. Think of it this way. If the cosmos were a vast ocean, then stars and planets would be its waves, endlessly rising, falling, reshaping. Some waves fade immediately, some collide, and a few, just a few, find a perfect rhythm that lasts long enough to build life upon its crest. Our solar system may be one of those waves. In the language of science, this idea sometimes appears in quiet corners of research, in astrobiology, in the study of self-organizing systems, even in the philosophy of cosmology. Not as proof, but as a curiosity. Could the laws of physics themselves learn through iteration? Could universes, or stars within them, act as natural experiments, refining conditions for life over time? Theoretical physicist Lee Smolin once proposed something like this: cosmological natural selection. The idea that black holes might spawn new universes, each with slightly different physical constants. Those that produce more black holes would reproduce more often, a kind of cosmic evolution, where universes experiment with themselves. It's a wild thought, and yet, so strangely elegant, Because if nature tests ideas on the largest possible scale, then our solar system might be one of its most delicate trials. A small corner of reality where gravity, radiation, chemistry, and time all met at the right moment to see what might happen. You could call it an accident, or you could call it learning. And if the universe learns, if it refines its own capacity for complexity, then life is not a side effect. It's a data point, a result, a living record of how matter behaves when given enough time to feel curiosity. Perhaps we are the universe's feedback loop, the part of the experiment that can finally reflect on itself. In a quiet sense, we are the data writing the conclusion. But let's not rush to meaning. Not every experiment has an observer. Not every process needs intent. Sometimes, the act of becoming is enough. Maybe the solar system is simply what happens when gravity, temperature, and chance find harmony, when the right ingredients stir themselves into something that can dream. From that perspective, every planet, every orbit, every comet trail is a note in the experiment's long unfolding. It's also possible that what we call rare isn't rare at all, only unobserved. That there are countless other systems like ours, waiting, quiet and unseen, orbiting suns too distant for our instruments to notice. Maybe the experiment isn't about rarity, but about scale, the universe testing how far it can spread its ability to create order. Still, the question lingers like starlight that refuses to fade. Why such precision? Why such care in the balance of distances, masses, and motions that let us be here at all? Some philosophers of science speak of fine-tuning, the observation that physical constants, from the strength of gravity to the mass of the electron, seem perfectly balanced to allow matter and life. Change them even slightly, and stars would not form, atoms would not bind, and consciousness would have nowhere to arise. Does that mean someone tuned them? Or that the universe itself is the tuner, adjusting through infinite experiments until balance is found? It's not an easy question, and maybe that's the point. Perhaps the universe is not built to give us answers, but to teach us how to live inside questions. To sit, as you are now, quietly, under the patient hum of the stars, and feel what it's like to exist inside an experiment that might never end. If you think of it gently, that's not frightening. It's comforting, because it means the unknown isn't our enemy. It's our origin. And to live, to wonder, to dream, is to participate. Even now, as you breathe, you are part of this experiment. The atoms in your body are performing their own ancient test, exchanging oxygen and carbon, releasing warmth, balancing energy. It's all the same physics, the same rules, repeating from the smallest cell to the largest galaxy. Maybe that's the answer hidden in plain sight. The solar system isn't a cosmic experiment done to us. It's one we are inside of, and always have been. So, as the night deepens around you, let the idea settle softly in your thoughts. You are a participant in the great unfolding of the universe. Your breath, your heartbeat, your quiet curiosity, all part of the same long process that began when starlight first met dust. And maybe, just maybe, the experiment's purpose is not to reach a conclusion, but to learn the art of continuing. Now that we've drifted through possibility, let's return for a moment to the language of evidence, the way the universe writes its story in numbers and light. You might imagine a scientist at their telescope, not staring through an eyepiece, but waiting for data to appear on a screen. The signal is faint, buried in noise. A tiny dip in starlight, repeating every few days or weeks. That dip means something has passed in front of the star, a planet, blocking just a fraction of its light. This is how we've come to know that the sky is full of other solar systems. Thousands of them, discovered by spacecraft like Kepler and TESS, each one revealing that stars rarely live alone. Almost every star seems to have planets. The galaxy is crowded with experiments in orbit, and yet, as the catalogue grew, a quiet surprise began to take shape. Most of those systems didn't look like ours. Many stars hosted super-Earths, planets larger than ours but smaller than Neptune, worlds that don't exist here. Others had gas giants so close to their suns that their atmospheres streamed away like tails of smoke. In some, planets orbited wildly tilted or stretched ellipses, not the neat circles we know. The pattern was strange. If our solar system were one data point among thousands, it would sit far out on the edge of the graph, a calm exception in a sea of extremes. Scientists began to ask, why? Was it selection bias? Our instruments more sensitive to close-in, massive worlds than to small, quiet ones like Earth? Or was our system truly unusual, a rare configuration amid a cosmic variety show? Research continues, of course, but the emerging picture is fascinating. Our Sun is relatively stable. Its planets are well spaced. It has no hot Jupiter, no super-Earths, no doubled suns to tangle orbits. And crucially, it has a giant planet, Jupiter, that formed early and far enough out to act as both protector and sculptor. Computer models show that systems lacking such a guardian often suffer chaos, planets colliding, orbits decaying, atmospheres stripped away. With Jupiter's mass drawing in comets, the inner planets enjoy relative peace, an environment where life could quietly evolve without constant interruption. So, the evidence suggests something subtle, not that we are unique, but that we are rarely balanced. A configuration where destruction and preservation hold hands. In science, rarity isn't proof of purpose, but it does catch attention. When patterns stand out, curiosity awakens. And curiosity, in many ways, is how the universe examines itself. To study these patterns, scientists use not just telescopes, but mathematics, the language of probability. They model disks of gas and dust, adjusting variables like temperature, density, and angular momentum. Each simulation runs like a miniature universe, evolving over millions of virtual years. Some yield chaos, some yield harmony, and once in a while, one yields something that looks astonishingly like home. But even here, humility guides the process. Astronomers know that we are still early in the observation. We've seen only a fraction of what's out there, and our methods favor the loudest examples, the biggest planets, the closest orbits. Quiet systems like ours may simply whisper too softly for our instruments to hear. And so, the data remain open, a cosmic riddle still half-written. Then there's the matter of life itself. Astrobiology, that tender science of maybe, looks for traces of possibility, water signatures, methane patterns, oxygen out of balance. We've found these hints, faint and far away, frozen oceans on Europa and Enceladus, the red dust of Mars once laced with rivers, organic molecules drifting in the tails of comets. All of them whisper the same thing. Life may not be unique to Earth. It may be a natural response to energy and stability, a process that begins wherever the environment allows. If that's true, then perhaps the experiment is broader than we thought. Maybe every solar system, chaotic or calm, is running its own version of the test, seeing how far matter can climb toward consciousness. And yet, even among this openness, there's the sobering paradox called the Great Filter. It's the idea that while life might emerge often, it rarely survives long enough to travel or communicate. Perhaps the universe is full of beginnings and few completions. Perhaps stability like ours is the narrow passage through which life must pass before learning to endure itself. So, where does that leave us? Surrounded by evidence both ordinary and profound. A solar system that obeys the same physics as all others, yet seems to have balanced them in a particularly enduring way. Planets arranged in resonant order, sunlight constant enough to nurture biology, chaos just gentle enough to allow curiosity. It's the kind of pattern that invites both science and wonder. Science, to measure its precision. Wonder, to ask what it might mean. If the solar system truly is a rare configuration, then its rarity itself becomes data, a result in the universe's experiment with possibility. A note in a much larger composition we are still learning how to read. So maybe the next time you look at the night sky, you can imagine each faint star as a page in a cosmic notebook, each one recording a different version of the same test. Some scribbled out by time, some still being written, some shining quietly like ours, holding steady in the dark. And as you gaze at that notebook, that endless spread of light and distance, Remember, science is not the opposite of mystery. It's the map we draw while walking through it. And every pattern we discover is both an answer and an invitation to keep wondering. If you've been following the thread of this story, you might have felt it, that quiet pull between awe and doubt, between the sense that the solar system is something special, and the humbling reminder that everything we call special is born from ordinary physics. Let's drift into that middle space for a while, the place where the skeptics rest, not to undo the wonder, but to understand it differently. Because perhaps what we call rare is simply what chance looks like when it succeeds. In science, chance isn't chaos in the human sense. It's structure without intention. The random dance of dust, governed not by purpose, but by rules that always apply. Gravity attracts, energy dissipates, matter seeks balance. Given enough time, those rules will sometimes produce astonishing order. Given even more time, they'll do it again. Maybe our solar system is just one of those countless repetitions, the one that happened to make it long enough for life to notice. The skeptics remind us, we see design because we are designed to see it. Our brains are built for pattern finding, for pulling meaning out of noise. It's how we survive, how we dream, how we build stories from stars. But sometimes, patterns exist simply because probability allows them to. Imagine flipping a coin 1,000,000 times. Eventually, by pure chance, it might land on heads 100 times in a row. It would look deliberate, astonishing, even meaningful, but the math would say otherwise. Perhaps our solar system is like that unlikely run of heads, improbable, but inevitable somewhere, sometime, in the vastness of the cosmos. There's also the anthropic principle, a philosophical reminder that says, of course the universe looks perfectly suited for life, because we are the ones looking. We can only exist in a place where the conditions are right for us to exist. If the solar system were too chaotic, too unstable, too harsh, there would be no eyes to observe it, no voices to wonder. So the fact that we can ask the question already biases the answer. In that light, the solar system isn't a deliberate experiment, it's a filter. We are here because we are here, and not anywhere else. It's not purpose that makes the pattern, but perspective. And still, that doesn't take away its beauty. In fact, it deepens it. Because if this harmony emerged from chaos, unplanned, unguided, without hand or mind, then it is all the more extraordinary. A cosmic accident that learned to wonder about itself. When you look closely, even chaos has a kind of order. Fractals, for example, those endlessly repeating shapes found in nature, from the branching of rivers to the curl of galaxies. They arise from simple rules, applied over and over again, without direction. And yet, they create forms of breathtaking complexity. So maybe the universe doesn't need intention to create art. Maybe it simply is art, the natural geometry of energy playing itself out. The skeptics aren't cold, they're careful. They remind us that meaning doesn't require a maker, that the solar system stability might be the natural outcome of physics selecting for endurance, that life could emerge wherever the math permits, and fade wherever it doesn't. And yet, even within that rational view, there's room for quiet reverence, because randomness itself, true randomness, is hard to find. Even in chaos, patterns whisper. Even in noise, structure hums. The physicist Murray Gell-Mann once said, "If you think you understand quantum mechanics, you don't." And maybe that's the deeper lesson of the skeptics, not to strip away mystery, but to remind us that mystery doesn't depend on belief. The universe is not obliged to be comforting or meaningful, and yet it often feels both. Maybe coincidence is the language of the cosmos, and we are just learning how to read it. Think about this. If the solar system truly formed by chance, without purpose or plan, then the same forces that shaped it are still shaping you. Every atom in your body obeys the same blind laws, and yet somehow they came together to create consciousness, something capable of love, imagination, and self-awareness. So even if everything is coincidence, it's a coincidence worth marveling at. Even if everything is chaos, it's a chaos that creates harmony. Perhaps the skeptic and the dreamer are not opposites at all, just two sides of the same gaze. One looks for reason, the other for meaning. Both find beauty in what they see. And as you breathe, as your mind drifts through these possibilities, notice how both ideas, randomness and purpose, begin to blur at the edges. Because maybe they aren't so different. Maybe what we call chaos is simply order at a scale too large for us to understand. And perhaps that's the soft truth hidden at the heart of all this. The universe doesn't have to choose between experiment and accident. It can be both, endlessly testing, endlessly becoming, endlessly beautiful. So, let your thoughts slow again. Let uncertainty feel like comfort, not confusion. Because even when everything seems random, everything is still connected, by gravity, by time, by curiosity. And that, in its own quiet way, is enough. Let's loosen our grip on facts for a moment. Set them gently beside you, like stones at the edge of a river. Now, let your thoughts drift, not to escape science, but to see where science might wander if it were allowed to dream. Close your eyes, if you can. Imagine yourself standing on the surface of another world, not Earth, but a pale, quiet sphere orbiting a distant sun. Above you, a sky of soft gold, two moons gliding like slow-moving lanterns. The air is thin but kind, and through it, you can almost hear the hum of gravity, that invisible music that keeps everything in place. Now imagine this world as one of billions, each a tiny note in the cosmic symphony. Each one slightly different, each one tuning itself to see what harmony it can make. What if, in some sense beyond our understanding, this entire universe is an ongoing experiment in variation, a grand orchestra of matter testing how many ways it can arrange itself into meaning? Maybe every star system is a line in a celestial poem, written by the laws of physics but edited by time. Some verses collapse, some explode, some linger in balance, singing softly for billions of years, like ours. And perhaps, among them all, the solar system is not the first or the only successful stanza. Perhaps it's simply one that survived long enough to wonder whether it was deliberate. Let's follow that idea a little further. What if advanced life, not necessarily human, but intelligent, reflective, once arose in some distant era, far beyond our reach? Not just on another planet, but in another epoch, long before the Earth had even formed? The universe, after all, is old, nearly 14 billion years. Stars lived and died for eons before our sun was born. Could some ancient civilization have seeded the foundations of what we now call the experiment? Not in a mythic way, not gods or architects, but as scientists themselves, exploring the boundaries of possibility. Maybe they wondered what would happen if they scattered the ingredients of life into young galaxies. Maybe they hoped that, somewhere, one of those seeds would awaken and begin asking questions of its own. And if that's true, then perhaps we are part of that chain of curiosity, life discovering life, experiment birthing experiment, consciousness looping back on itself, a recursive wonder, stretching through time. Now, let's shift the lens again. What if the experiment isn't about life at all? What if it's about balance, testing how matter and energy can coexist in harmony before entropy pulls them apart? Our solar system, with its stable orbits and long quiet ages, might simply be one of the universe's successful trials in maintaining equilibrium. A sustained harmony, brief on cosmic scales, but long enough for awareness to arise and ask, why? Or, consider this. What if the experiment isn't something being run on us, but through us? What if consciousness itself is the feedback mechanism, the way the universe measures its own complexity? When you think, when you wonder, when you lie awake under the weight of the stars, maybe you are the experiment observing itself. Maybe awareness is the test result, the cosmos learning that it can feel. These ideas sound vast, but they're not so far from physics. In quantum theory, observation affects reality. Particles exist in uncertain states until they're measured. And some physicists have even speculated that the act of observation, of awareness, is woven into the fabric of existence itself, not as a cause, but as a condition. Without the observer, there is no experiment. Without the question, there is no answer. So perhaps the solar system's rarity isn't about design, but readiness, a place where the universe finally became aware enough to look at itself and say, "Ah, there I am." Now picture this thought experiment. The solar system as a cosmic terrarium, a carefully balanced garden where sunlight, chemistry, and time combine to see what kind of story matter can tell. Planets as test environments, Earth as the one that bloomed, Mars, Venus, and the icy moons, the control groups, their fates recorded as alternate outcomes. If that's true, then maybe evolution isn't random adaptation. Maybe it's the universe iterating, refining, learning what works. And if so, then we are not separate from that learning. We are the learning. Every moment of curiosity, every attempt to understand, every whisper of what if, all of it is data. All of it feeds back into the grand experiment of existence itself. But then again, maybe that's just us making poetry out of probability. And that's all right. Because poetry, in its way, is the human form of physics. We describe patterns we don't yet have equations for. We give language to awe. So, as you lie there, imagine the solar system not as a static machine, but as a living question. A gentle, spiraling question that's been turning for billions of years, asking in silence, how far can order stretch into meaning before it dissolves back into chaos? And maybe, just maybe, your very act of listening tonight is part of the answer. Because to be aware of the question is to be part of it, to breathe in rhythm with the stars, to wonder without needing to know. That's how the universe keeps its experiment alive. So, take another slow breath. Feel how small and infinite you are at once. And let the thought settle, like dust on a quiet planet at dawn. You are not outside the experiment. You are one of its most beautiful results. Let's imagine, just for a while, that it's true. That our solar system really is part of some grand cosmic experiment. Not an experiment in the laboratory sense, with hypotheses and controls, but something deeper, more graceful. An experiment in time, in balance, in possibility. What would that mean for us? Perhaps it wouldn't change anything practical. The laws of physics would still hum their steady tune. The planets would still spin. The tides would still pull at the edges of the sea. The moon would still rise slow and golden over the horizon. But maybe it would change the way we feel about being here, about being part of something so vast that it needs no name. If our solar system is a rare cosmic experiment, then it means the universe isn't static, it's curious. It tries things. It tests arrangements. It allows for mistakes, for collapses, for strange successes like us. It learns through time, not through intention, but through persistence. Think of how life emerged on Earth, from the simplest chemistry to the complexity of a nervous system that can feel wonder. If that's not an experiment in consciousness, what is? Every creature, every cell, every act of adaptation is a hypothesis written in living form. The Earth has been running this quiet, patient test for nearly 4 billion years, refining its designs through endless trials of chance and change. So maybe the solar system isn't a rare result. Maybe it's a rare moment in that ongoing process. A configuration stable enough, gentle enough, for awareness to take root. And here we are, the observers, the ones through whom the experiment finally looks back at itself. Pause here for a moment, and feel that. You, listening now, you are the way the universe measures its own beauty. You are the proof that chaos can give rise to calm, that randomness can build meaning, that stardust can learn to dream. If the solar system is an experiment, then every human story, every poem, every act of kindness, every curiosity is data in its unfolding. Not data to be judged, but data to be witnessed. The experiment isn't about success or failure, it's about experience itself. And perhaps the most extraordinary implication of all is this. The experiment doesn't end with us. It continues through us, in the ideas we share, the technologies we build, the empathy we feel for each other and for the fragile world we live on. In a sense, Every time you wonder about the stars, you're continuing what the solar system began, a dialogue between matter and meaning. So what is the goal of this cosmic experiment? Maybe there isn't one. Maybe it's open-ended, a question without a final answer, a melody without a final note. The purpose of the experiment might simply be to exist, and to keep existing in ever more intricate, self-aware forms. And if that's true, then wonder itself is sacred, not in a religious sense, but in the quiet, unspoken sense that wonder is how the universe celebrates itself. Every act of curiosity, every night spent looking up instead of down, is part of the same continuum of exploration that began when the first atoms formed after the Big Bang. Even our doubts, our scientific rigor, our insistence on evidence, those too are forms of reverence. To measure the universe carefully is to show respect for its mystery. To question is to love with precision. And in that way, perhaps the experiment is not something being done to us, but something being done through us. Maybe the universe doesn't have observers. Maybe it becomes observers. Maybe the solar system is not a sample in a test tube, but a neuron in the brain of something unimaginably large, thinking itself into existence one star at a time. And if that's true, then you, lying there, listening, letting your breath slow, are part of the same great thought. You are the awareness flickering inside the experiment. You are how the cosmos feels its own heartbeat. So, if we are the experiment, then perhaps the lesson is simple. Be gentle with it. Be kind to the world that runs it. Because the data we create are not in numbers, but in experiences, in empathy, art, discovery, and love. Every quiet moment of reflection, every question whispered to the night sky, feeds back into the experiment's purpose, whatever that may be. Maybe the solar system doesn't just test physical laws. Maybe it tests meaning. And in that, perhaps we are the most important part of all. So, rest easy. Let the weight of cosmic possibility soften into calm. You don't need to solve the question. You just need to feel it, the quiet joy of being part of something vast, mysterious, and still unfolding. Because even if the solar system is just one experiment among trillions, it's the one that gave rise to you, and that makes it precious beyond measure. There's a quiet moment, just before sleep, when thoughts no longer line up in order. They begin to float, fragments of memory, flashes of color, half-remembered ideas gently spinning like planets in orbit. It's in that space, between awareness and dreaming, that the universe feels closest. Because maybe that's what the universe does too. Maybe it dreams. Not in the way we do, not with symbols or stories, but with matter and motion, with light and gravity. Every star, every planet, every cell, a fragment of a larger dream unfolding through time. And perhaps consciousness, yours, mine, all of ours, is the dream becoming aware of itself. If that's true, then we are not observers at all. We are participants. We are the dreamer and the dream, the experiment and the question, the echo and the origin. When you look up at the night sky, you're not gazing at the universe, you're gazing from within it. Your eyes, your thoughts, your heartbeat, they are all made from the same particles that burn in stars and drift through galaxies. You are not a visitor in the cosmos, you are a continuation of it. A localized awareness of an endless process. Maybe that's what people once meant by the word soul, not something separate from nature, but nature becoming aware. A self-sustaining spark of reflection in the endless dark. And so, if the solar system is an experiment, perhaps its real result isn't the planets or the chemistry or even life itself. Perhaps the result is wonder, the ability to ask why, and feel that question as something beautiful, not frightening. To know we don't know, and still love the mystery for what it is. That kind of humility is rare, even in a vast universe. It's the balance point between curiosity and surrender, the point where science and spirituality touch fingertips and realize they've been walking the same road all along. In that sense, you, the listener, lying there, are not separate from the great unfolding. You are one of its instruments, humming softly in the dark, tuned to the frequency of awareness. The universe looks through your eyes to see its own light. It listens through your quiet thoughts to hear its own silence. And maybe that's what the experiment was always meant to reveal. That matter, when given enough time, becomes meaning. That energy, when allowed to slow and cool and gather, learns how to love. So as you breathe, slow and steady, imagine that every inhale draws in starlight, and every exhale releases gratitude. You are part of a cycle billions of years in the making, and it moves effortlessly through you. The solar system, the galaxies, the cosmic web, they are not out there, waiting to be understood. They are within you, unfolding at the same pace as your thoughts. The experiment continues. The universe dreams. And tonight, you are one of its most beautiful dreams, a flicker of awareness floating softly through the dark, bringing warmth to the cold perfection of space. So rest, cosmic observer. Let the universe think through you for a while. Let it breathe in your place. Because even as you drift into sleep, it continues, quietly, endlessly, dreaming itself forward, one gentle consciousness at a time. So now, we return to silence. The kind of silence that lives between the stars, patient and endless. The kind of silence that hums beneath everything. The quiet pulse that began long before you were born and will continue long after every orbit fades. The solar system turns slowly, always turning. Planets drift along their paths, so constant, so unhurried. The sun breathes in light and breathes it out again. Dust settles on the faces of distant moons. And all the while, the experiment continues, gently, rhythmically, without hurry, without need. Maybe it doesn't seek answers anymore. Maybe it simply rests in its own balance. A great, calm system of motion and pause, just as you are now, breathing, floating, waiting for nothing but peace. If you could stand outside of time and watch the solar system from afar, you would see a slow dance lasting billions of years. Tiny arcs of light looping endlessly, gravity weaving them together like threads of silver. From here, tonight, your breath matches their pace. You are turning with them, a participant in the grand rotation, a quiet witness to the long night of creation. Perhaps one day, far beyond our lifetimes, the sun will cool and fade. The planets will drift apart. The experiment will end, or perhaps begin again, in another form, another sky. But tonight, it continues, through your heartbeat, through your calm attention, through your willingness to wonder. So let go now. Let your thoughts dissolve, like light fading beyond the horizon of memory. Let your body settle, heavy and safe. The universe is vast, but it holds you gently. You are not falling through space. You are floating in it, supported by its quiet equilibrium. Every sound fades now. Every question grows softer. The solar system keeps its watch, the stars keep their distance, and you drift quietly within it all, a brief and beautiful awareness in an ocean of night. Rest now. The experiment continues. And somewhere, in the stillness between worlds, the universe dreams with you.